So I was watching a video about black holes with my 11th grade last week, and to their excitement and my slight pedagogical disappointment, the video revived in the total gore of what it's like when you fall into a black hole and how it turns into spaghetti and how you get ripped apart and all that stuff. So physics is actually provides a lot of great material for the horror movie sector there, but what I'll be talking about today is actually not the physics of being ripped apart, but what happens actually the moment that you cross that boundary into the black hole. So the story starts with one ingredient, which is a very popular ingredient, a guy with a really great hairdo who said, well, E equals mc squared. But what we're looking at today is actually not this is not really relevant to us, but actually an equation like this, which is called g mu nu E plus lambda g mu nu is equal to 8 pi t mu nu, which is another way of a physicist at a party will try to impress you with this in the version of the shape of space-time is proportional or is related to the content, the energy and the mass that's inside of it. So basically, all of us warp space-time in one way or another. Some of us warp it more than others, and if you warp space-time so much that perhaps your younger siblings don't stop leaving you alone anymore, or light even starts to stick to you, then you've probably exceeded what we consider human capabilities and become what physicists call a black hole. So in 1915, this opened the $1 million TV quiz question, which was, what is the shape of space-time around these black holes? What is it around these really heavy objects? Is it like a triangle? Or is it more like maybe a cylinder? Or is it, a donut? And this guy called Schwarzschild called up and said, hi guys, I got you covered. I have this idea. So black holes are usually kind of round, and they usually don't move. So what happens to space-time is it should probably also be round, and it shouldn't really move. And basically he wrote this down, this kind of equation, which is a very complicated mathematical way of saying exactly the same thing. And while God may have looked at creation and thought that it was good, Schwarzschild looked at his equation and he said that actually it was really, really bad, because he saw that when he approached this black hole at a radius of 2gm, that part of his geometry exploded. And then actually what happens is that as you got closer to this point, 2gm, that it looked like the person was never reaching that point, that they would get slower and slower. And it's like this movie scene where, you get into slow-mo, and at some point you just go off and do something else because, or maybe you die of old age in the meantime and you never know what happens in the end. So the big question that we have is what happens actually if this person, it looks like their time is apparently stopping. Does that mean from their perspective that they can see the future, that time is accelerating, that they see the whole universe future passing in front of their eyes? Well, unfortunately, the answer to this is no, and this is probably also why it didn't make its way into this high school physics video. And the reason is that this geometry that Schwarzschild wrote down is dependent on the observer. So it's related to a very specific set of coordinates. So if you change the coordinate system, and in physics, this fortunately doesn't amount to throwing, this doesn't amount to throwing innocent mice down a black hole and asking them for a report card afterwards, but basically it's just you change the coordinate system and you do all your computations again, and then you arrive at the conclusion that unfortunately nothing really happens when you fall into a black hole. But I guess rest assured, if you do fall into a black hole, you do have a few minutes left to get all of your things off your bucket list, and then actually indeed it turns you into spaghetti. Thank you.